All right, everyone, I'd like to welcome you to our 11 a.m. press conference, and we have retired Rear Admiral Tim Gallaudet here to introduce the Arctic Report Card 2019. Thank you.
Okay, good morning, everyone. How are you all today? You guys can do better than that. All right, good morning. Well, this is a really significant event here at AGU, announcing our latest Arctic Report Card for 2019. This is the third time that I've had the privilege to be able to make this announcement with our team and represent our world-class scientists who are really performing such incredibly cutting-edge work and research to better understand the dramatic changes that are occurring up in the high north. And much as with previous years, you'll hear that the changes up in the Arctic are happening faster than anywhere else in the globe. And it's our mission at NOAA to characterize those, to understand them, and to predict them. And that's part of our larger mission, to observe, understand, and predict changes and the environment all around the planet. And I think most of you are familiar with the National Oceanic and Atmospheric Administration. We are an organization of 20,000 federal employees and affiliate partners that perform research and conduct science and perform environmental services in all our U.S. territories and states. And we do this with a great network of international and academic partners. We have 16 research ships, 9 aircraft, some of which fly through hurricanes and perform critical soil moisture and ice surveys. And we also have about 8 supercomputers. We have about 400 technical divers. And of all our scientists, 900 or so about have PhDs. So we are really leading the way in the nation in characterizing these changes that are happening and predicting them. And so first off, though, you've heard me talk about our larger priorities at NOAA, and this is just context for today's event. We have 2. We've focused on improving our weather forecast by following the Weather Forecasting and Research Innovation Act of 2017, which was just reauthorized this year. So here I am up in our weather forecasting office up in Anchorage, and these are the folks that are really, on the front lines of all these changes, forecasting the severe weather that occurs in this region to protect lives and property. And the Weather Service folks we have are really heroes. They put in long hours, they work nights and weekends, just like this last Thanksgiving period, to really keep Americans forewarned and safe. And it really is probably more important than anywhere in the Alaskan region. And so that's one of our top priorities, is improving our weather forecasting capability and advancing our model. And Dr. Jacobs, the acting administrator, is doing great work there. It's important, too, because the observations that we make in the Arctic region are critical for the downrange predictions in the continental U.S. So really, understanding what's occurring in the Arctic will help us understand better and predict what will happen outside of the Arctic. Our other top priority is what we call our blue economy priority, and that is to advance the sustainable economic contributions of our oceans, coasts, and Great Lakes. And that is comprised of several areas. First and foremost, ocean mapping, exploration, and prediction. And you see a depiction of the Arctic seafloor there. And just last week, a very, very notable event occurred. The President signed a memorandum to advance our ocean mapping, exploration, and characterization work. And so it involves several areas, one of which is to better map the Alaskan shoreline and nearshore. And so we're developing a strategy to do that. We're developing a national strategy with other agencies to advance our mapping in our exclusive economic zone. And we're also looking at improving the permitting for research that occurs in our oceans. And all very good work and very exciting part of our blue economy priority. Other areas that we're focused on are fisheries, sustainable fisheries. And Alaska, it has the largest sustainable fishery in the world, and America's largest by volume. And so that is an area that we're also seeking to advance. Major changes are occurring that you'll be hearing about today. For example, we closed the cod fishery early, first time in a long time because of the decline in the stocks there. So our fishery science really is important now to ensure we better manage what's occurring. You also have on the converse side, commercially viable species moving into the Arctic region. So much dynamic occurring, and we are working to characterize that and predict it better. There's other areas that we're focused on in our blue economy priority, like coastal resilience, and you'll see with the retreating sea ice that the coastal areas of Alaska are seeing much more rapid change and erosion, so forecasting that and supporting local communities in the planning is also very important. And mind you, the work that NOAA is doing is about informing decision makers. I've had people come to me and say, what are you doing to combat these changes? And it's not our job to combat these changes. It's our job to characterize them and predict them better so that we can inform policymakers and decision makers. Now, there's several other areas that are enabling our advancements in observation and prediction. Here you see NOAA Alaska Fisheries Science Center scientist named Katie Sweeney, and she's operating, obviously, an aerial drone up in the Pribilof Islands, where she's doing surveys of northern fur seals. This is one of many technologies we're advancing to improve NOAA's understanding of changes in the Arctic and elsewhere. We're also working to advance other types of unmanned systems like underwater gliders, remotely operated vehicles from our ocean exploration ship, hybrid vehicles, and as well as unmanned surface vehicles that we've used extensively both in the Arctic and outside the Arctic to characterize change and what is occurring in the environment. And then we're also leveraging artificial intelligence, machine learning, environmental DNA and genomics, as well as cloud computing and several big data projects, all to improve what we're doing and really transform our ability to characterize and understand our environment. Now, lastly, I'll share with you an interesting example, and it's not going to be a highlight of this event right here today, but I just wanted to give you a little flavor of all that NOAA does in the Arctic and elsewhere. What you see here is a depiction it's imagery from the USS Abner Reed's stern gun mount. One is of the actual ship on the upper left there in 1942. The other is our discovery of that ship's gun mount just recently with researchers from Scripps, just off the island of Kiska, Alaska. And this ship was sunk during the Battle of Kiska that occurred during the Battle of Midway. It was a diversionary event, a strike by the Japanese. And so we used several cutting-edge technologies with my Scripps classmate, Dr. Eric Terrell, who's on the ship there in the middle, using unmanned underwater drones, towed vehicles, as well as side-scan sonar to discover this wreck. This is what they call an underwater cultural resource. And so of all that NOAA does to characterize our environment, it includes things like this, because I just want you to understand there's the physical environment, there's the biological environment, but people matter too, and certainly our maritime heritage and history. And by learning about that and rediscovering it, it helps us really keep our focus on keeping our competitiveness and our world-leading stature, not just in defense, but also in science. Now with that, let me just close by saying that we are going to continue to be there in the Arctic, conducting great science with partnerships. And in fact, in the room here today is Dr. Gijs de Boer, and where are you, Gijs? There you are. Stand up, please. Gijs gave a great presentation yesterday about work for the Mosaic expedition on the Polar Stern. It's a wonderful international collaboration. He will be going out there in a few months, and he's going to be contributing the unmanned aerial systems to do the observation up there. So that's how we're moving forward. We're working with our international and academic partners to improve our understanding in really innovative and revolutionary ways. And so the scientists today who will speak before you, they will show you all that we've learned now, and keep in mind that we're going to do much more to learn more in the future. Now with that, I will start with a video before our speakers.
Unprecedented warming and exceptionally low levels of sea ice are imposing dramatic, rapid, and disruptive change on marine ecosystems in the far north. The Bering Sea has been nearly ice-free for 2 winters in a row. the warmer water has caused marine species to move farther north, impacting vital commercial fisheries and indigenous subsistence harvests. There has been a cascade of impacts on the marine food web, from microscopic creatures to large marine mammals. Massive die-offs of seabirds and other animals were seen. This years-long pattern of climate warming and ice loss in the Arctic is likely to continue, threatening ecosystems and livelihoods with far-reaching global implications. The loss of ice, snow, and permafrost in the Arctic is causing damaging changes to the northern landscape. In 2019, the Greenland ice sheet continued melting at a dramatic rate. This will inevitably contribute to widespread coastal flooding in the years to come. Thawing of permafrost ecosystems in the Arctic is now releasing carbon to the atmosphere at a rate of up to 600 million metric tons per year, accelerating climate change. Changing growing conditions, including warmer summers, decreasing snow cover, and permafrost instability, lead to alterations in the vegetation of the Arctic landscape. This can strongly affect habitat for caribou, birds, and other wildlife, putting further pressure on northern ecosystems and communities. Indigenous communities along the Bering Sea are on the front lines of climate change. As sea ice disappears, so does hunting access to seals, whales, walrus, and other marine life.
There's less and less snow, and there's less and less ice. And that means trouble, not only us hunting and fishing, but the animals that we depend on.
We're seeing a lot of birds die off every summer. It's really gotten worse within the last 5 years. The lack of ice really hurts our food chain.
More open water exposes shorelines to storm surges, flooding, and increasing erosion. Despite the stresses of climate change, resilience is also a way of life for the region's indigenous peoples.
There's a lot to protect today before a total disaster happens.
Good morning, everyone. My name's Matthew Druckenmiller. I am one of the editors of the Arctic Report Card, and I wanted to first begin by acknowledging the other editors. Our lead editor, Dr. Jackie Richter-Menge of the University of Alaska Fairbanks, and Dr. Martin Jeffries of the Cold Regions Research and Engineering Lab, who's with us today here in the audience. The NOAA Arctic Report Card has been issued annually since 2006. and is a peer-reviewed source of the most recent environmental information on the current state of different components of the Arctic environmental system relative to historical records. This year's report card was authored by an international team of 81 scientists from 12 different countries and addresses 12 different topics that you will find are very much interrelated. And this year, for the first time, the report includes a chapter by Indigenous peoples of the Arctic. Each year, the report focuses on reoccurring topics, which we refer to as the Arctic's vital signs. Tracking these vital signs each year is made possible largely by satellite observations, which now have been consistently tracking Arctic change for several decades. Other topics that require non-Arctic satellite-based observations are reported on less frequently, for example, permafrost. And the report also addresses new and emerging issues. This year, for example, we have included a focus on the recent extreme changes in the Bering Sea. So it is in this way that the Arctic Report Card achieves a comprehensiveness over time that would not be possible in any given year. Yet still, in 2019, even if all of the pieces are not included in this year's report, it is clear that a consistent picture is emerging. Taking together, this year's essays serve to highlight the many strong and complex connections within the Arctic system. It is these connections that magnify the impact of the changing Arctic environment, changes that affect ecosystems and communities on both regional and global scales. At the center of the changes observed throughout the Arctic is the persistent warming of surface air temperature. The average annual surface air temperature over land for 2019 was the second highest since 1900. The 6 hottest years on record in the Arctic have all taken place in the last 6 years, with 2016 as the record hottest. These observations clearly reveal an Arctic that is warming at more than twice the amount of global mean air temperature increases, which began around 1980. And as shown here in this map of deviations from average temperature in 2019, you can see that the most extreme warming was centered over Alaska, where temperatures were well warmer than average throughout the year, and especially throughout the winter months. Now let's turn to related warming of ocean waters. The average sea surface temperature in August 2019 were anywhere from 1 to 7 degrees warmer than average across most Arctic seas, with the highest temperatures observed in the Chukchi, Laptev, and Kara seas, along with Baffin Bay west of Greenland. With the exception of a slight cooling trend in the Barents Sea, the bigger picture reveals significant warming trends in average sea surface temperatures across nearly all of the summer ice-free regions of the Arctic. This warming is very closely connected to declining Arctic sea ice, which Dr. Perovich will talk to here in a moment. Also observed across Arctic waters is a continued rise in primary productivity, which has been estimated through satellite observations for the last 17 years. Primary production is the process by which marine algae, through photosynthesis, transforms dissolved inorganic carbon into organic carbon, providing energy to the marine food web. All ice-free regions of the Arctic Ocean continue to exhibit increasing ocean primary productivity, with 2019 observations well above the 17-year average. On land, the warming surface air temperatures that we had just shown are driving further change. We continue to observe declines in snow cover across the Arctic. For the months of May and June, we see a 15% decline in snow cover per decade since 1981. This long-term satellite record also continue to confirm widespread greening across the Arctic tundra regions, especially at places like the North Slope of Alaska. This year's Arctic Report Card includes an essay by Dr. Ted Scher, summarizing conclusions from a new set of regional and winter measurements of carbon dioxide fluxes from permafrost ecosystems. This essay suggests that permafrost, which when it thaws experiences a microbial conversion of its stored carbon into greenhouse gases. This thawing of permafrost may now be acting to accelerate global climate change. In addition to these large-scale transformations that I've described across the Arctic, this year's report card also highlights more regional examples. An essay on fisheries in the Bering and Barents Seas summarizes the northward expansion of non-Arctic fish species, driven by increasing bottom water temperatures linked to less sea ice. There is an essay on the ivory gull, which is a high Arctic seabird that closely resides near sea ice throughout its annual migration. This report documents how the breeding population across northern Canada has declined by 70% since the 1980s, likely due to both stress from a changing environment and contaminants which have been found in these birds at record levels. Lastly, the recent warming and unprecedented low sea ice conditions in the Bering Sea offer an excellent yet highly worrisome example of the strong connections within the Arctic environment and the implications for ecosystems, but also for the region's indigenous peoples. And with that, we turn to Dr. Perovich to discuss two additional key drivers of the Arctic system, sea ice and the Greenland ice sheet.
It was another year of significant ice loss in the Arctic, both on land and in the ocean. There was substantial loss of sea ice, as we can see here, compared to the long-term averages, particularly around the periphery of the Arctic Ocean. The annual minimum sea ice extent in September was the second lowest of the satellite record, tied with 2007 and 2016. It was 33% less than the average between 1981 and 2010. The 13 lowest summer ice extents have been in the past 13 years. When you look at this, you can see that the September ice extent has never returned to the pre-2007 levels. There are also changes in the age of the ice. The oldest ice older than 4 years old, it tends to be the thickest ice and hence the most resilient ice. Back in March of 1985, this comprised around 33% of the sea ice cover and covered an area roughly the same size as the United States east of the Mississippi. Now in March of 2019, it's 1% of the ice cover, and all that's left is an area the size of the state of Maine. There are also changes in Greenland. Their observations of the Greenland ice sheet from fall of 2018 through 2019 revealed dramatic ice loss. Surface melt started early, around mid-April, 6 to 8 weeks before the long-term average. Roughly 95% of the surface of Greenland ice sheet underwent melting during the summer of 2019. The extent and the magnitude of the ice loss rivals that of 2012, the previous record year of ice loss. This rapid ongoing change across Greenland is evident in observations of surface melt area, total ice loss, and surface albedo. Some of these changes are happening close to home. For example, the sea ice changes we're seeing in the Bering and Chukchi Seas. Just like the previous year, the Bering Sea had little ice most of the 2018-19 winter and through the spring of 2019. There were also large decreases of sea ice in the Chukchi Sea. In the Chukchi Sea, melt occurred roughly a month earlier than usual. This resulted in very rapid ice loss in the spring of 2019. By the end of the past summer, the ice extent in the Chukchi Sea was one of the smallest in the record and well below the 1981 to 2010 average. This reduction in ice cover extended far into the fall freeze-up season. In mid-November, the amount of ice in the Chukchi Sea was only 1/3 of what had been the previous record minimum. And most characteristics of the Chukchi Sea now are different than they were earlier in the satellite record. Now, it's critical to realize that these ongoing changes are not just a collection of statistics. These changes are affecting people today. Our next speaker is Melissa Johnson, who's a Nupiaq and originally from Nome, Alaska. She is the executive director of the Bering Sea Elders Group, which works to protect and respect traditional indigenous ways of life, now and for future generations, with guidance by Alaska Native elders.
Is it the arrow? Spacebar. Okay. Okay. Uvla Lotak, good morning. Wanga Maktoyak Sitnasa Murunga Pangmakak Kisagving me Inyurunga Johnson Koyaharunga Alan Johnson Jr. Liu, Sarah Jack Liu, Atataka, Alan Johnson Sr. Liu, Teresa Norbert Liu, Suli Edna Alexander Liu, Raymond Sidamona Liu, Suli Louis Jack Liu, Daisy Noakak Liu, Executive Director me, Bering Sea Elders Group me. So good morning. My Inupiaq name is Maktoyak. My English name is Melissa Johnson. I'm originally from the community of Nome, Alaska. I come from the Johnson family. My parents are Alan Johnson Jr. and Sarah Jack, and I have 3 sets of grandparents: Alan Johnson Sr., Teresa Norbert, Edna Alexander, Raymond Cinnamona, and I was raised by Louis Jack and Daisy Noyakuk, originally from Shishmaref. So a couple of months ago, we had an opportunity to share our perspectives on the ever-changing Bering Sea from the guidance of our elders, and we had also the opportunity to have good weather in our favor. No one got fogged in their communities. There wasn't high winds to limit our elders from traveling as far as St. Paul, Alaska, and a little bit north from Nome, from Wales, Alaska. So these are our elders that have contributed to this topic. And we actually have one in the audience right now, Jerry Ivanoff from the native village of Unalakleet. Jerry, it's right there. So thank you to our elders for this opportunity moving forward. So this image here is some of the communities that have contributed. We have the community of Chivak, Alaska, Savunga, Alaska, Unalakleet, Alaska, Golovin, Alaska, Wells, Alaska, Teller, Alaska, and Nome, Alaska. This picture here is what we are dreaming of today. The ice from all the way down to St. Paul, and also St. Paul. But you see on the ice came all the way down to St. Paul, and it's all the way, north into the Chukchi Sea. This year, we are in the second week of December. We don't have this luxury today. Our communities are significantly impacted by the lack of sea ice that we have today. We have many areas that are unsafe for travel, unsafe for hunting, unsafe for our future, and significantly impacts our food sources that we rely on as Indigenous people along the Bering Sea coast. So the lack of sea ice makes it very difficult for us to navigate both on land and on the sea. There are areas within our communities that we used to be able to go from snow machine, from one community to another. Our hunting was significantly easier. Our ice fishing was also easier. But fast forward into 2019, we have a lot of slushy, dangerous areas that are impacted, by the climate changing. Our hunters are finding it more difficult to navigate on the land and moving out into the sea. 5 or 10 years ago, our sea ice was about maybe 5 to 10, maybe 20 miles outside of our communities. And now it's at minimum 50 miles out, is where the sea ice is. And it's having treacherous impacts to our hunters, and it's our hunters who provide the food that we rely on as Indigenous people. Foods such as seal, walrus, beluga, bowhead whale, and also our seabirds and many of our fish species. So this is another image of the tundra. That's actually, as I mentioned previously, this is something we would like to see right now, but it has been significantly windy the last few weeks, and a lot of our snow has been blown away. Transportation from, from one community, it could be as little as 5 miles away from the community to the Bering Sea. It's very dangerous. The sea ice and the snow helps us maintain our indigenous way of life. And so with that being taken away each year, and within the last 3 years taken away significantly, we haven't had the opportunity as the past to continue having vast amounts of our seal, walrus, different fish, and even our land resources such as blueberries, salmon berries. We call them blackberries, but scientists know them as crowberries, cranberries, and our different greens like beach lovage is a common word that I've heard, but we in the Norton Sound area, a common word you'll hear is tagayuks, and so our different, we've had significant impacts to our different food sources that we can't buy in a local grocery store. If you're from the San Francisco Bay Area, you have the luxury to go to your grocery store and buy chicken, buy your beef, buy whatever type of salmon. We don't have those luxuries. When the sea ice and when the snow comes, that is our replenishment of our food sources. So the lack of sea ice has also significant impacts to our marine animals and bird life that we rely on. I come from a family of hunters, and I, seek a lot of guidance as well from my elders who were also hunters when they were younger. And, the hunters, they make mention to the preparers, who are usually women, that like this top left picture here is of a bearded seal, or we know it as ugruk. The fat content is significantly less, which means that's less seal oil that we utilize for another food source. We also utilize the skin for different purposes, including making garments such as boots or shoes like I'm wearing. But also, like the image of the walrus there, the lack of sea ice is impacting their feeding grounds. It's also impacting the reproduction cycle of marine mammals. The delicacy of having clams inside a harvested walrus is no longer, because they're not able to go to the seafloor and seek out their food sources, and then they have no ice to rest upon. Another area that is impacted significantly in regards to our land animals, for example, this is a ptarmigan here. It's doing its correct biological system, transforming itself to mirror the landscape of which it's on. So, it's in a willow. There's snow in the background. It's mimicking the willow with the brown. But because of the lack of sea ice, the lack of winter, the lack of snow, it's still doing its biological process, but there's no background for it to mimic. So it's making it easier for other prey to, target it. The same thing with our Arctic foxes. It's easier for prey to target them as well, and just making it significantly different or difficult for those food sources. So why does it matter that climate change is occurring? Why does it matter that, that we don't have any sea ice? Isn't it beneficial for our world's economy? It may be, but because of the lack of sea ice, because of the lack of snow, because of the lack of winter, going from in Alaska, we really appreciate 5 feet to 10 feet or more of snow every winter. That means that our fish have plenty of spring water to go up, in the spring into the summer months. That means our berries are more plentiful. That means that our walrus, our ugruk, our seal, all of our animals that we rely on as Indigenous people, that means we can continue to feed our people, continue to have our ceremonies, continue our language, continue many other practices because of sea ice and snow. Without that, we become limited, we become isolated, we become continuously sparse in our sharing. Our berries are, because of the climate change occurring, our berries are becoming ripened significantly faster, which means if we don't hurry up and pick because we're attending a conference, for instance, that means we may be without, those nutritious resources to last us through the winter. And our different fish, for example, and our seals and our seabirds, we're harvesting them and we're finding that their stomachs are full of plastics, are full of styrofoam. They're washing up they're just coming up belly up, and they're not good for human consumption. We wouldn't even feed them to our dogs who are, in some of our communities, our dog is our mode of transportation help because of the high cost of living. But we also have, many other components where, we don't have the luxury to just go to a convenience store and purchase our foods. With the high energy prices in rural Alaska, it makes it very difficult for us to continue our way of life. So our reliance on sea ice is very crucial to our future generations. And it's been our elders who have continued to guide us throughout these ever-changing times, to say, here's what you're going to see, and when those changes come, here's how to prepare, for those changes. There's been a lot of unpredictability, as I had mentioned. We used to be able to look at the different weather patterns, especially the types of clouds that are coming in, whether it be, we're going to experience fog, we're going to have a lot of rain, or it's going to be clear enough to where we're able to go out hunting and fishing and gathering, whereas now it's very unpredictable. And that unpredictability, again, causes us to rely more on food sources that don't have a holistic connection. We don't know, we don't have, by the time we get, for example, a banana into town, by the time it's shipped from wherever, whether it be, somewhere here in the lower 48, and it comes to our hub, our biggest community, Anchorage, and then it's shipped out of Anchorage to rural Alaska, we're expecting it to be not ready for banana bread. By the time we get it, that is the way our produce is. And that's one example of a food source that, we don't rely on a daily basis. It's really a lot of our elders, with this reliance of our foods, they're acclimated to seal meat, to seal oil, to our berries, to our greens, and sharing. And so we just had a holiday come up a couple weeks ago. You know, like how many in this room enjoy paying $50 to $100 for a turkey, a little 10-pound turkey? Imagine that for, there's enough people in this room right now that this is a small Alaska Native community, and we have a lot more luxuries by having salmon strips, having berries for Eskimo ice cream, having ugruk for our dried meat, our seal oil, an opportunity to make clothes. So the lack of sea ice we are significantly impacted by. It is our way of life. It is how we have continued for generations as Indigenous people, and it's going to continue to impact us moving forward. So, Kuenakpak for NOAA for providing this opportunity for an Indigenous component, and for our elders for our continued guidance.
Thank you, Melissa. I wanted to now ask the various contributors to the Arctic Report Card that are here with us today in this room to stand and come to the front of the room to be recognized and potentially to field questions pertaining to your contributions. As I mentioned, we had 81 scientists contribute this year, many of which are here today at AGU.
We're now going to open the floor to questions from reporters only. Please state your name and where you're from when you ask the question. Do we have any questions from reporters in the audience? Just raise your hand.
To mitakoye, shante wastea nape iuzapele, nanet naha Lakota, Dakota, Chalagi, Naha, Alameda, and Matahan. Tanyayagli. I just said in my language, which is Dakota and Lakota, and that was only Lakota. Hello, my relatives. My name is Nanette Dietz, and I didn't know how to say I work for Indian Country Today. That's my newspaper. But I live in Alameda, and I said, from my heart, I extend my hand to you and say hello. And Tanyayagli means you represent all of you in a very good way. And my question is to Melissa Johnson. Thank you very much, Pedami Aye, for all of you, really, for what you've said today. My question is, how are you planning as an Indigenous community to actually, if you must, leave your villages or move your villages? Or in my mind, I go back to the buffalo, of course, and all of our food sources we traditionally also had to rely on. And they are, of course, pretty much extinct. So my question is, with this huge problem occurring for everyone around the world, actually, how are small Indigenous communities going to survive this? Will there be help from other people? Will there be, because it looks clearly to me, I see that this will continue on a worse pattern. So what happens to the traditions, the language, the way of life, so that it can continue? Because we struggle every day to continue our language, our way of life, our traditions, our dances, our songs. It's very difficult. So my question for you, Melissa, and for anyone else who would like to, as scientists, please tell us, what can we do so we do not repeat history over and over and over again?
Quiana, for the question. So I think one of the first questions you had asked is, what are we doing as Indigenous people to adapt to our environment with the continuing changes of our climate? We as Indigenous people, we have always adapted to our environment, whether something was imposed upon us or not. In this regards, the climate change is significantly impacting us for Arctic peoples because we've always had the same food sources for thousands of years. We've always had the same, weather patterns that we can predict. We've always had the same language that we use. We've had same ceremonies. So we are continuing to adapt to our environment as it changes. And with those adaptations, our connections with other indigenous individuals has become stronger. We've had different food sources come into our regions that we may not be familiar with, harvesting, processing, preservation, that we communicate with our other indigenous bodies and just ask how do we do this. And for moving forward, it's mother, the Mother Earth is doing what she needs to do because we are not taking care of our land and sea as we have been given. So we're going to continue to adapt and move forward with the change. In regards to our heritage and ceremonies and culture, we're going to continue maintaining those and incorporating our youth into the conversations moving forward, because it is our youth that will continue to seek guidance on how things used to be, what to prepare for. The only thing that's different is we are in this generation as opposed to 100, 200, 500 years. It's this generation is, we've had many climate changes. And so it's just up to us to continue to adapt and not just stay, stagnant in what's going on today.
More questions from reporters in the audience?
Kit Stoltz, Santa Barbara Independent. Could you talk, Admiral Gallaudet mentioned that observations from the Arctic are critical to understanding what is going to be happening in the lower 48. Could one of you folks talk about what is happening in that research?
Hi, my name is Mo Ying Wang from University of Utah, University of Washington, sorry, and also work at the PMEL NOAA in Seattle, Washington. So one of the current research regarding that is because the changing sea ice conditions, we have the feedback to the atmospheric circulation. And so the circulation pattern change, that will affect the mid-latitude weather. So it's very the topic is emerging, it's new. So there are quite some debates. The observational evidence has proven there's connection, but some of the models that they prove the same concept. Well, there are some other model simulations show slightly different result. So it's a very challenging topic, and we're still working on that. But we believe, recently, actually, I just talked to one colleague yesterday at his poster, and he developed series prove that that's probably true. So looking forward to their publications.
Hi, Marco Tedesco, Lamont Doherty, Earth Observatory, Columbia, and I lead with Twyla the Greenland section. The same heat wave that warmed up Europe in August was the same process that basically created a lot of melting on the ice sheet, then created the new record, so to say, or close to record. So all the events are connected in this way. The geographic boundaries really don't exist when you look at these things. And the observation that we have included the buoys in the Arctic Ocean, the radiosones, the balloons in the atmosphere, the satellites, they all help us to put together the pieces that we need to understand, because linking the mid-latitudes to the Arctic is one of the most imperative things to do, both from a modeling perspective, also to understand the processes and the consequences of these processes.
Yes, go ahead.
My name is Ted Schur. I'm from Northern Arizona University. I was the author of the permafrost carbon essay that Matt introduced. Thinking about how the Arctic influences the rest of the world, this emission of carbon from the Arctic is one of the key topics. Carbon dioxide and methane locked up in permafrost can be released to the atmosphere, and so that's something we're seeing with a warming Arctic. Now that carbon doesn't stay there, it influences global climate change everywhere, it essentially accelerates this process, so that's another mechanism of how a changing Arctic feeds back to everybody, no matter where we live. Thanks.
Do we have more questions from the audience? Questions from reporters? Questions from the chat? No? Oh, yeah, one there. She's got you behind you.
Peter Sinclair, Yale Climate Connections. Dr. Schur, the changes in the permafrost, would you characterize those as unexpected, or are we tracking kind of where we thought we'd be? Just kind of characterize that a little bit.
Yeah, that's a great question, and I'll have to beg the indulgence of my science colleagues up here because we know the Arctic's warming, as Matt pointed out, and we're losing ice, and that's easy. Carbon is a little bit more challenging because we have releases of carbon dioxide and methane, but we also have a greener Arctic. Plants are growing more and taking up CO2. So we have carbon moving in both ways, and that's the real challenge in terms of both observing what's happening today and forecasting to the future. Now, one thing that I wrote about in this year's report card that summarizes a lot of research is many new synthesis measurements that are really pointing to the fact that this net release, this increase in atmospheric carbon dioxide is already underway. And so I would say that that's sort of a fundamental change, thinking about something we used to say this could happen in the future to something that may be already happening today. So I would like to highlight that as part of this year's report card. Thanks.
Do we have any further questions? Yeah.
Hi, Wade Gibbs, freelance. I'm interested in the second derivative of this sea ice change. The rate of change, what is the rate of change of the rate of change? In other words, is it increasing? Are we seeing this a steepening curve, or is it shallowing out? It looks like the cycle, it might be a cyclical event that will eventually reverse.
Yeah, I think if you look at it, typically people draw a straight line to it, which in that case, the second derivative doesn't come into play. If you look at the record, there's a lot of variability from year to year. If you look more closely at the record, you can see that in earlier years, back in the 1980s and even into the 1990s, there was a gradual downward trend, some ups and some downs. And then things started to get steeper at the end of the 1990s into the 2000s. And for me, at least, it became real in 2007, where we had, at that time, the all-time record minimum set by a record amount. The decrease from 2006 to 2007 was, and still is, the largest year-to-year drop in sea ice. Interestingly, a year before, a model study had talked about RILES, rapid ice loss events. And that's basically what we saw. You know, since then, we've never returned to those levels. There was another record minimum set in 2012. There's been some ups and some down, but it's been the lowest it has been, tied for second this year. And so there's definitely been changes. What exactly the second derivative is, you know, would be hard to say, but the changes have been increasing. And there is always the concern, will we see another one of these rapid ice loss events? And, you know, we can't really predict that.
All right, unless we have any last question. One question on chat, go ahead.
Yura Throzen of Arctic Today asks, what are the most striking changes in Bering Sea fisheries? Do you think these changes like Pacific cod and pollock moving north will be permanent?
So I'm Kevin Wood. I'm at PMEL. So the latest NOAA survey, trawl survey results are showing a really rapid increase of northward movement. So there's a lot more fish in the northern Bering than there have been before. It's hard to say whether that's going to continue from year to year because the cold pool of these fish respond to can come back if we get a southerly event like 2012. But I think in the long run, we're going to see more and more events like we were seeing this year. And so there may be some gaps where there's a rebound perhaps, but I think this is going to turn out to be fairly typical in the not too distant future.
Okay, last question, and I think we'll do. Oh, you would like to add? Yes.
The question you asked about the cod and the pollock moving north, we're very concerned about that as Alaskan Native people, because as the temperatures warm, our resources, it takes farther for us to travel for our resources. This year, the king crab in the Norton Sound, our king crabbers were only get half the resource because we're 7 to 15 degrees warmer, and the crab didn't come in where they normally come. So it's changing the migration of our marine resources that we depend on. And it's definitely going to hit us right here on the stuff that we like to eat.
I think we have to close there, folks. If you have further questions, our panelists and our authors will be up here for a few minutes. Thank you to our panelists, and we'll see you again at 1:30 for the next press conference on Earth's oxygenation.
Nice.